I established IDAC Ireland Limited, having worked in industry myself for 20 odd years, and we've established in 1997 to provide finite element analysis consultancy and CFD consultancy to industry in Ireland. We focused very quickly on medical devices because the medical device industry in Ireland is strong, and so we've got about 10 years detailed experience now in simulation of medical devices, quite specifically stents and stent delivery systems. I worked for GE Aircraft Engines in Cincinnati back in 1990 and started using Ansys while there. When I came back to Ireland then, I worked for a small company and implemented Ansys at that company. So it's what I've always known, but it's been able to deliver what's been necessary. It's a very competitive world, so people are having to compress design cycle times, and FEA or simulation is a tool that's very effective at doing that. So design engineers now are being asked to design better products more cheaply and more quickly, and they need tools to do that. Stent manufacturer will come to us, they're designing a new stent and they're trying to optimize the design of the stent. So they need to get the stent so that it's deliverable. It needs to have good bending characteristics. It needs to have good fatigue performance. It needs to have correct radial strength for the application, etc. So we simulate the behavior, structural behavior of the stent, and we can look at several designs. We feed back information on the first design. We make recommendations as to how the design can be improved, and then the customer will typically come back with a few modifications, 3 or 4 stents perhaps, and we'll simulate those, and then we can compare and then move on to the next stage of optimization of the stent and identification of a robust stent design. There's 2 types of stent. There are balloon expandable stents and there are self-expanding stents. So we simulate behavior of both of them. So with a balloon expanded stent, we simulate the crimp process where the stent is crimped onto the balloon. We simulate the balloon expansion process, the release of the balloon, which leaves residual stress, and then subsequent fatigue of the stent. And the full strain history is required, so you can't just sort of skip to the deployed stent. You have to model the complete process to properly simulate the fatigue and performance of the stent. And for the self-expanding stent, we model the expansion process, which is a manufacturing process, and then the crimp into a sleeve, and then subsequently the deployment into the vessel and fatigue. And again, you need the full strain history. And the self-expanding stents are typically nitinol, so we use a nitinol material model which is in Ansys for those. So it models the hysteretic behavior of the material. We, along with other partners, develop tools which will allow us to take medical images and in less than 1 hour convert those medical images into a computational fluid dynamics model in Ansys, run a transient CFD analysis over a single cardiac cycle and present results within 5 or 6 hours, and extract and interpret results and present it in a clinically relevant way so that clinicians can make sense of it. I think fundamentally you make your most important decisions right at the beginning of a design process when you've least information. So simulation can provide information to help you make robust decisions. And I think if you get a design right at the beginning, you reap the benefits from that all the way through. Everything seems to just fall into place. So get something fundamentally right at the beginning, which simulation can help you do, and you've got a good design.